1 mole of equimolar mixture of ferric oxalate and ferrous oxalate will require X mole of KMnO4 in acid medium. So what is X? 1 mole of equimolar mixture of ferric oxalate and ferrous oxalate. First you should know what is the formula of ferric oxalate and what is the formula of ferrous oxalate. In this, which part is getting oxidized by KMnO4, and 1 mole equimolar means half mole ferric oxalate and half mole ferrous oxalate are with you. Let's go for the complete solution. Ferric means Fe plus 3, oxalate is C2O4 minus 2. Ferrous means Fe plus 2, oxalate is C2O4 minus 2. So the formula will become Fe2C2O4 taken thrice. This is for ferric. FeC2O4, this is for ferrous. First you should know the formula, then only you can answer. In this, Fe plus 3 cannot be oxidized because it is in the highest oxidation state, but C2O4 minus 2, the carbon is in the plus 3 oxidation state, that can be oxidized to carbon dioxide. Correct, by KMnO4. Here Fe plus 2 is there, so it can be reduced, it can be oxidized to Fe plus 3, and this carbon is again oxidized to carbon dioxide. So here both are getting oxidized, Fe plus 2 as well as C2O4 minus 2. But here Fe plus 3 is already in the oxidized form, highest form, so only C2O4 minus 2. So how to answer? See carefully. Fe2 C2O4 taken thrice. In this we have no issues with iron, only carbon. Like that, how many carbons are there? 6 carbons are there. All the 6 carbon atoms from plus 3 oxidation state, they will turn into 6 carbon atoms of plus 4 carbon dioxide. So change in oxidation state is plus 1. Like that, 6 carbons are there, so the change will be plus 6, you can see. Only irons are not undergoing oxidation, carbon atoms are undergoing oxidation from plus 3 to plus 4. So change in oxidation state will be plus 6. For 1 mole bit, if you are taking 1 mole, the change in oxidation state is going to be 6. But we have only half mole. For half mole, the change in oxidation state will be only 3. Or you can say plus 3 is the change in oxidation state for half mole of Fe2C2O4 taken thrice. Next, if you see FeC2O4, ferrous oxalate, iron is oxidized to Fe plus 3. Change in oxidation state is from plus 2 to plus 3. So for iron purpose, it is plus 1. C2O4 will be converted to 2CO2, where the oxidation state is changing from plus 3 to plus 4. So for 2 carbons, the change will be plus 2. Iron change is plus 1. For carbon, change is plus 2. So total change will be plus 3 if we are taking 1 mole. But as we mentioned in the question, equimolar mixture, half mole Fe2C2O4 taken thrice, half mole FeC2O4. So it is also again, we have half mole only, so the change is 1.5. So total number of electrons you require here is plus 3 and plus 1.5, means for 1 mole equimolar mixture you need 4.5 mole of electrons. 4.5 mole of electrons, or you can say the change in oxidation state is 4.5. See carefully. In Fe2C2O4 taken thrice, iron is not getting changed. Iron is not getting changed. C2O4 only undergoes the change. But in case of ferrous oxalate, iron will be converted to Fe plus 2 converted to Fe plus 3, C2O4 minus 2 converted to CO2. So total change is 4.5. Now coming to KMnO4. KMnO4 changes in acidic medium to Mn plus 2. The change in oxidation state from plus 7 to plus 2. So change is minus 5. Minus 5 is the change. That means if you are taking 1 mole KMnO4, change will be minus 5. But we need only 4.5. That means 5 mole of electrons are involved in 1 mole of KMnO4. But we need only 4.5. So for 4.5 change, how many moles is required? 4.5 into 1 by 5 is nothing but 0.9 mole. Because 1 mole 5, less than 5 we need. You can easily calculate 0.9 mole KMnO4 is required. One interesting question it is.